Hello and welcome to this lesson on visualizing polymers. In today's lesson, we will develop skills to recognize polymers from given diagrams. By drawing and recognizing polymer diagrams, we will enhance our ability to visualize these important materials at the molecular level, which is crucial for understanding their properties and applications in everyday life. This will enrich our comprehension of how the chemical bonding principles we've learned apply to larger, more complex molecules, further broadening our insights into the world of chemistry. Let's delve into the new technique for drawing diagrams for polymers and recognizing polymers from those diagrams. Firstly, let us recap what a polymer is. A polymer is a large molecule that is made up of repeating smaller units known as monomers. These monomers are covalently bonded to form long chains. Note that in this lesson, we will not dive too much into the details. This is because, for your Unit 1 exam, you are only expected to recognize polymers from diagrams. We will learn how to draw the diagrams in more detail in the organic chemistry unit. Also note that we will be referring to substances such as ethene and chloroethene, which you may not have seen before. We will also examine those in the organic chemistry unit. For now, we are only interested in them as examples to illustrate polymerization. To draw a polymer, we need to identify the repeating unit, which is the simplest part of the polymer that repeats over and over again within the chain. Let's take polyethene as an example. The monomer for polyethene is ethene, C2H4. When ethene forms the polymer, the double bond breaks, and the carbons are linked in a chain with single bonds. The chain can be extremely long, so when representing polymers, we do not draw the chain. Instead, we represent it as in this diagram. Let us analyze the key features of this diagram. First up, repeating units. The most important feature of polymer diagrams is the repeating unit. This is the smallest section of the polymer that repeats over and over to form the entire polymer chain. Repeating units are shown in brackets to indicate that they repeat multiple times. Then we have the subscripts. A subscript outside the bracket indicates the number of times the unit repeats. Un is used to represent a large, unspecified number of repetitions. Bond lines extend from the brackets, indicating that the repeating units are connected to form a long chain. Let us examine another polymer as an example. Suppose we start with the monomer 1,2-dichloroethene, which has the shown structure. During polymerization, the double bond between the carbon atoms in the monomer breaks. Hence, the repeating unit will only have a single bond between the two carbon atoms. And furthermore, it would have bonds extending outside the brackets to show how the units link together in the chain. As before, we have an N subscript to indicate that the repeating unit repeats numerous times. We can also represent this as a polymer chain by drawing the repeating unit a few times. The polymer formed from the polymerization of 1,2-dichloroethene is polychloroethene, commonly known as polyvinyl chloride or PVC. This long chain represents the polymer with the repeating unit linked together. By understanding these diagrams and recognizing the repeating unit, we can identify polymer structures efficiently, aiding us in understanding their properties and uses in various applications. In today's lesson, we focused on drawing diagrams for polymers and recognizing polymers from these diagrams. We started by understanding that a polymer is a large molecule consisting of repeating smaller units called monomers, which are covalently bonded to form long chains. We then learned how to draw polymers by identifying the repeating unit, which is the simplest part of the polymer that repeats within the chain. Using polyethene as an example, we saw how the ethene monomer's double bond breaks to form single bonds in the polymer chain, resulting in the repeating unit, C2H4. We illustrated this repeating unit inside brackets with bonds extending out to show connections to other units, indicating a long chain. Next, we practiced recognizing polymers from diagrams by identifying the repeating unit enclosed in brackets and noting the extending bonds that show where the units connect. For instance, recognizing the repeating unit, C2H4, allows us to identify the monomer as ethene and the polymer as polyethene. Overall, this lesson enhanced our ability to both draw and recognize polymer structures, providing a deeper understanding of their properties and applications. This skill is essential for interpreting and visualizing polymers at the molecular level, which is crucial for advancing our knowledge in chemistry.